Hey YouTube, it's Brendan with a video describing how to solve system of linear equations word problems. When solving a system of linear equation word problems, there's really a few steps to keep in mind. The first step is you first need to define your variables. You can use x and y, or you can try to use more descriptive letters. For example, in the first problem, I will use A for adults and C for children, so it's easier to keep track of which variable's which. Then you're going to set up your equations. For these types of word problems, we're usually going to be setting up two equations. And then we'll either use substitution or elimination to solve. So let's take a look at problem 1. Stacy is selling tickets to a football game. The tickets cost $20 per adult and $10 per child. If Stacy sells 200 tickets in total and earns $3,200, how many adult tickets did she sell? And then how many children's tickets? So the first thing we're going to do is we're going to define our variables. So here, like I said before, I'm going to let A equal the number of adult tickets, and I'm going to let C equal the number of children's tickets, or child tickets, either one. And then what we're going to do is we're going to go ahead and set up the two equations that come out of this. Now, if the tickets cost $20 per adult, if I take 20 and I multiply it by A, that would give me the total cost of all the adult tickets. And if to that, I add 10 times C, because it's $10 per ticket, and I multiply it by the number of child's tickets that I sell, that would give me the total cost of tickets for all the children. And I know that in total, Stacy's going to earn $3,200. So if I take those two values and I add them up, I should get $3,200. Now we also know that Stacy sells 200 tickets. So if she sells A adult tickets and C child tickets, then if we add those two numbers together, they should equal 200. Now at this point, we can choose to solve the equation two different ways. We can either use substitution or elimination. I like elimination here because I can see that the variables are kind of lining up pretty nicely. So if I'm going to solve this by elimination, what I want to do is I want to multiply this whole second equation here by 10. Why am I going to do that? Because I'm going to get the C's to match up. The coefficients on the C's will match up if I do that. So if I multiply this by 10, I get 10A. If I multiply this by 10, I'm going to get 10C. And if I multiply 200 by 10, well, that's just going to add another 0 here. I then know that I can subtract these two equations from each other in order to get the C term to eliminate. So I'm going to put a little subtraction sign out front and subtract straight down. Now 20A minus 10A is going to give me 10A. 10C minus 10C is just going to cancel. And 3,200 minus 2,000 is just going to give me 1,200. So I can divide both sides by 10, and I would find A is equal to 120. So this means that Stacy was able to sell 120 adult tickets. Now, if I want to figure out the number of children's tickets, what I'm going to do is take this value and plug it back into either of these two equations. I'm going to choose to plug it into the first. So we would have 20. Now I'm replacing A with 120, so I'm going to put 120 in for A. Plus 10C is equal to 3,200. Now 20 times 120 is going to be 2,400 plus 10C is equal to 3,200. I go ahead and I subtract 2,400 from both sides, and I have 10C is equal to 800. And then I would find C is equal to 80 after I divide both sides by 10. So we can see here that Stacy sells 80 children's tickets and 120 adult tickets. And that makes a lot of sense because that adds to 200, right? That's the total number of tickets that Stacy was going to sell. Next, we can go ahead and take a look at the following problem. So Roger is buying seeds for his garden. Tomato seeds cost $2 a pound, and potato seeds cost $3 a pound. He's buying 40 pounds of seeds and spends $107. How many pounds of tomato seeds did Roger purchase? And how about how many pounds of potato seeds? So we're going to go ahead and walk through our steps again. Step one is we have to define our variables. So here, I think it makes a lot of sense to let T equal the total number of pounds. So it's going to be pounds of tomato seeds. And then we're going to let P equal the pounds of potato seeds. P for potatoes, P for tomatoes. Now, we're then going to do what we did last time, where we go ahead and we set up our equations. So if tomato seeds cost $2 a pound, if I take 2 and I multiply it by the pounds of potato seeds, this is dollars per pound times pounds, I'm just going to get the total cost, the total amount of money that Roger spent on tomato seeds. And I'm going to add that to 3 times P, and I'm going to find that these two numbers add to give me 107, right? The total amount spent on tomato seeds plus the total amount spent on potato seeds should equal $107. Now we also know that he buys 40 pounds of seeds, so if I add up the pounds of tomato seeds and potato seeds, this should equal 40. Now I can just as easily solve this with elimination, but because I did that last time, I'm going to go ahead and do substitution here. And when we do substitution, we have to solve one of the equations for one of the variables and then substitute it in. So I'm going to take the second equation, I'm going to subtract P over to the other side, and I'm going to find T is equal to 40 minus P. Now I'm going to take this value and I'm going to plug it in for T in the first equation. So I'm going to have 2 times 40 minus P plus 3P is equal to 107. Distributing the 2, I would get 80 minus 2P plus 3P is equal to 107. Combining like terms, 80 plus P is equal to 27. Got ahead of myself there. 80 plus P would equal 107. Subtracting 80 from both sides, I would get P is equal to 27. Now, once we know P is 27, we can take that and plug it in for P in this equation to find T. So T would equal 40 minus 27, which would give me T is equal to 13. So we know that Roger sells 27 pounds of potato seeds and 13 pounds of tomato seeds. Now we'll go ahead and take a look at the final problem here. So the area of a rectangle is 48. Now this requires you to remember a little bit about geometry, and just remember that the equation for area is equal to length times width. So if the area is 48, we could say that 48 is equal to length times width. Now the second part, the width of the rectangle, is 2 more than the length. Well, width being 2 more than the length, mathematically it would become the width is equal to the length plus 2. Now we can go ahead and substitute in for W here. So basically, since this is already solved for W, it makes sense to plug that into this equation. So we could say that 48 is equal to the length, and then instead of W, I replace it with L plus 2. Now when I distribute this, I'm going to find that 48 is equal to L squared plus 2L. And we have to ask ourselves, what kind of equation is this? Well, this is a quadratic equation. We know that because we have an L squared in L in a constant term. So anytime you have a quadratic, you have to bring everything to the same side. And then we have to factor. So for factoring, we're thinking of two numbers that multiply to negative 48 and add to 2. So those numbers would be L plus 8 and L minus 6. Setting each of these factors equal to 0, we would find L could either equal negative 8 or L could equal positive 6. Now one of these answers doesn't really make sense. You can't have a negative length, right? Like I never take out a tape measure and measure something and say, oh, that's negative 5 meters. No, we just say it's 5 meters long. So this negative number is an extraneous solution because we can't have that. And then L is 6 is going to be our actual length. Now once we know L is 6, we can take that number, plug it back into this equation over here, and to determine that if L is 6, W equals L plus 2 becomes W is 8. So W would equal 8. So our length would be 6, and our width would be 8. And that's how you solve some system of equations, system of linear equations word problems. I hope you found this video helpful. Thank you for watching.